Welcome to Succeed e-learning app. Today we are going to learn a new chapter by name circles. So what are circles? Circles, as you already know, are a collection of points from a fixed point. That is, let us say on a plane, if you mark a point there and take a same distance and go on marking the points around it, so that when you join becomes a circle. So in this circle, the fixed point is nothing but center of the circle. So the fixed distance from the center to any given point on a circle is called as radius. Next, we move on to understanding what is called as circumference. So circumference is usually a length of the figure. So now, how do I calculate the length or the circumference of a circle? So to visualize this circle, if you cut it at one end and stretch it, it becomes a line. And whatever is its measure would be the circumference of a circle. Diameter. Any line which is starting from one point of the circle and reaching another point of a circle through the center of the circle is called as diameter. We also say that diameter is twice the radius. So if I represent radius by r and diameter by d, we can say that d is equal to 2 times of r. Chords. Chords are the lines which starts from one point on a circumference and reaches to the other point on the circumference. This need not necessarily pass through the center of the circle. If it passes through the center of the circle, then we call it as diameter. Diameter be the lengthiest chord of a circle. So you saw that chords divide circle into two different halves. It could possibly be equal or unequal. So these two separate areas are called the segment of a circle. So if you observe here, now if I draw a chord, there is two different segments which is formed. An arc is any part on the circumference. So if you observe the circle, any given part on the circumference can be called as arc. Okay, it can also be a semicircle. Now, if you draw the radius at the end points of these two arcs and shade it off, that particular region is called as sector of a circle. Consider a circle and draw a line PQ in such a way that it does not intersect circle at any given point. Then this line is called as non-intersecting line. Consider another circle and draw a line in such a way that it intersects the circle at two distinct points P and Q. This line is called as secant of a circle. Now consider a third circle in such a way that you mark a tangent or a line in such a way that it intersects a circle at just one point. And this particular line is called as tangent to the circle. The point where the tangent touches the circle is called as point of contact. Now let us mark this point of contact as C. Draw the radius from the center of the circle in such a way that it's perpendicular to the tangent and make sure you touch the point C. Now, if you observe that the angle is 90 degrees. So, consider a circle and a point P. Draw a tangent from P to any given point on a circle. Also, from the same point P, draw another tangent to the circle. Now, if you measure the length of the tangent from the point to the intersecting point or the point of contact, the length of these two tangents will be same. And as you know that tangent is a special case of secant. You saw that a tangent can intersect a circle at only one point, which is nothing but the point of contact, and a radius which is drawn from the center of the circle to this point is always perpendicular to the tangent. Now, Let us prove the same with the help of a theorem. Consider a circle with the center O. Draw a tangent xy and in such a way that it intersects the circle at a point P. This is nothing but your point of contact. Now, mark a point Q on the line xy such that it is outside the circle and join OQ. Point Q must lie outside the circle. Why? Because if point Q lies inside the circle, then xy becomes a secant and not tangent. Therefore, OQ is longer than the radius OP, which implies that the length of OQ is greater than the length of OP. Since this happens on every point on the line xy except the point P, OP is the shortest of all the distances of the point O to the points of xy. Therefore, OP is perpendicular to xy and any tangent will intersect the circle at only one point. Through this, let us get to the conclusion of the theorem. Let us move on to the next question. Two tangents TP and TQ are drawn to a circle with the center O from an external point T. Prove that angle PTQ is equal to twice of angle OPQ. Let us get into the proof of this question. Consider a circle with the center O and an external point T. Draw a tangent to the circle at the point P and Q on the circle in such a way that you have two tangents TP and TQ. Now, TP and TQ are the two tangents that you have. Also, draw the radius OP and OQ. Now, join PQ at the point R. Therefore, let angle PTQ is equal to theta. We know that TP is equal to TQ from the theorem that we have already learnt. In the diagram, if you observe that the line OT is common to both the triangles OPT and OTQ. Therefore, you can write it as the triangles are isosceles triangles. Therefore, triangle TPQ is equal to angle TQP, which is equal to half into 180 degree minus theta. Why 180 degree? Because we know that the sum of angles, all the three angles of a triangle is equal to 180 degree. Therefore, this is equal to 90 minus theta divided by 2. That is, angle TPQ is equal to 90 degree minus theta divided by 2. We know that angle OPT is equal to 90 degree. So, angle OPQ is equal to angle OPT minus angle TPQ. When you substitute, you get it as 90 degree minus 90 degree minus theta divided by 2, which is also equal to 1 divided by 2 into theta. So, we have already assumed that theta is equal to angle PTQ. When we substitute that here, we get this is equal to, or the angle OPQ is equal to half the times of angle PTQ. By cross multiplying, you get OPQ is twice of angle PTQ, or you can also write it as angle PTQ is equal to 2 into angle OPQ, and hence the answer is arrived. Now, let us look at the last problem in the section. PQ is a chord of length 8 cm of a circle of radius 5 cm. The tangents at P and Q intersect at a point T. Now, find the length of TP. So, let us get into the problem and construct the circle in order to arrive at the solution. Consider a circle with a center O. Draw a point T which is external to the circle and draw two tangents TP and TQ from this point. Now join PQ at a point R. Also join OT. Let it intersect PQ at a point R. Then triangle TPQ is isosceles because we also learnt it in a previous problem that OT is a common side to both the triangles OPT and OQT. Therefore, both of these triangles are isosceles triangles. Now, OT is the angle bisector of the angle PTQ. So, OT is perpendicular to PQ and therefore OT bisects PQ, which gives us PR is equal to RQ is equal to 4 cm. Also, OR is equal to square root of OP square minus square root of PR square from Pythagoras theorem, which is equal to square root of 5 square minus square root of 4 square. Now, angle TPR plus angle RPO is equal to 90 degree, which is also equal to angle TPR plus angle PTR. So, angle RPO is equal to angle PTR. Therefore, right angle triangle TRP is similar to the right angle triangle PRO by angle-angle criterion, which we had learnt in the triangles chapter. This gives us TP by PO is equal to RP divided by RO, which is equal to, substituting the values of PO and RO, we get TP by 5 is equal to 4 by 3, or TP is equal to 20 divided by 3 centimeters. Note that TP can also be found by using Pythagoras theorem. So this is as follows. Let TP be x, that is TP is equal to x, and let TR be equal to y. Then we can write it as x square plus y square is equal to 16 from the triangle PRT. Mark this as equation 1. Consider triangle OPT. Here we can write it as x square plus 5 square is equal to y plus 3 the whole square. Substituting both of these equations, we get 25 is equal to 6y minus 7, or you can also write it as y is equal to 32 divided by 6, which is equal to 16 by 3. Therefore, x square is equal to 16 by 3 the whole square plus 16. Now, resolving this, we get x square is equal to 16 by 9 into 16 plus 9, which is, in substitution, we get x square is equal to 16 into 25 divided by 9. This is from the equation 1. Therefore, on cancelling out the common terms and doing the math, we get x is equal to 20 divided by 3 centimeters, which is exactly same as the value that we had got in our previous method of resolving this problem. This concludes the chapter circles. I hope you enjoyed learning with us. For more such videos, keep watching Succeed e-learning app.